All right, here are quiz 4 solutions for Math 112. A couple application problems from logs and exponents. First one tells you invest $100 in an account, it earns 25% interest compounded continuously. How long will it take for your account to be worth $200? Okay. Well, we have this formula. It tells you that the amount of money you have at time t is equal to the amount that you start out with times e raised up to whatever your interest rate is times the amount of time. This is our continuous compounding interest formula, I guess. So what we want to know is how long, we're going to solve for t, will it take so that the 100 that you start with turns into 200 if your interest rate is 25%. In other words, solve this equation right here. Okay, if you're going to try to solve this, you got to get t by itself. It's up in the exponent. It's a little bit difficult. We can take the log of both sides, but before you do that, it would be beneficial to divide both sides by 100. And the reason that's beneficial, 0.25t, yeah, I'll just leave it like that. The reason that's beneficial is now when you take the natural log of both sides, the natural log of e raised up to the 0.25t is just 0.25t. So therefore, to get t by itself, multiply both sides by 4, and you get that t is equal to 4 times the natural log of 2. Just because I know people will write it this way, I'm going to say or the natural log of 2 divided by 0.25. Because when you look at this, you might think to divide by 0.25 instead of multiplying by 4 means the same thing. I think this is prettier, but there's two forms. All right, moving on. Half-life problem. So we have the half-life of this stupid example. Half-life of something is 4 years. Half-life of my sorrow from the Ducks losing in the national championship game. Whatever. Half-life is 4 years. How much, if I start with 100 of this stuff, how much is there left after 2 years? And you might think, well, let's see, if the half-life is 4 years, then after 2 years, maybe you'd have 75% left or something. It doesn't work out that way. But the way you can figure it out is actually using this formula. So the amount that I have is equal to the amount that I start out with times e raised up to the rate times the time. Unfortunately, I don't know the rate. But since I know the half-life, I can figure out the rate. So using the half-life, using the fact that, where's the half-life? The half-life is 4 years. When t equals 4, what I have is exactly half of what I started with. So if I started with 1, for example, I'll only have 1/2 left after 4 years. Something like that. That's written kind of ugly. I can rewrite that as 1/2 is equal to e raised up to the 4r power. You don't have to say 1 times, and r times 4 is 4r. But you can solve this for r by taking the natural log of both sides and then dividing by 4. Sure. Natural log of 1/2 divided by 4. Fine. That is your rate. And once you know the rate, you can kind of use that in your formula to figure out whatever the hell you need. So in this problem, it's saying how much of Brian's 100 grams remains after 2 years. So if you start with 100 and your rate is this mess, the natural log of 1/2 divided by 2. When your time is equal, sorry, it's divided by 4. Copying this rate from down here. When your time is equal to 2, so r times t would be that thing times 2, the question is, how much remains? I guess this would work as your answer. I mean, it's not the prettiest thing in the world, but it's equal to the answer. There's no variables in here. It's a number. Fine, that's your answer. However, it says up here that it can be written in this form, and if you can write it in that form, you get extra credit. And I could use some extra credit, so let me try to write it in that form. So first, let's simplify. The natural log of 1/2, this thing, is being divided by 4 and then multiplied by 2. But dividing by 4 and multiplying by 2 is the same as dividing by 2, which is the same as multiplying by 1/2. So I'm going to say this exponent here is 1/2 times the natural log of 1/2. This 1/2 coming from 2 divided by 4, essentially. And why I read it like that is because I want to get it into the form where it's e raised up to the natural log of something, which I almost have. In fact, I can apply my third log rule here to take this number and bring it up into the exponent of this exponent. What I'm saying is I can rewrite this as the natural log of 1/2 raised up to the 1/2 power. Weird looking, but fine. This simplifies nicely. E raised up to the natural log of something is just equal to that something. So I get 100 times 1/2 raised up to the 1/2 power. In other words, 100 times the square root of 1/2, which is damn near what it asked for here. And realistically, if you get this, I bet the grader will take pity on you and give you the extra credit point. However, it says A and B should be whole numbers. It's not a whole number, it's a fraction, 1/2. But you can deal with that. You can rewrite this as 100. Or should I write this? Maybe I'll jump up over here. 100 times the square root of 1 divided by the square root of 2, which you can then rationalize. If you multiply the top and the bottom by the square root of 2, you get 100 times the square root of 2 divided by 2, which is the same as 50 times the square root of 2. And this right here will be extra credit answer, whereas any of these will be fine for your answer. Okay, moving on. Completely different topic. Trig. This is unit circle stuff. So this first one asks you, maybe I should just sketch a unit circle. It'll probably come in handy for this problem. Yeah, I guess that's a circle. That's the worst circle I've ever seen. But whatever, it'll work. Here's my unit circle. Because it's a unit circle, the radius is 1. So the diameter is 2. And since the circumference is the diameter times pi, it's 2 pi to get all the way around. So if 2 pi gets me all the way around, then pi gets me over to here. Half of pi just gets me up here. 1.5 pi gets me going down here. Kind of gives, maybe I should have written that lower. That looks like I'm labeling the center. Because we measure from here counterclockwise. And so pi over 2, well, that's just going straight up right here. So really what it's asking you for is, if you're asking the sine of pi over 2, if you remember that the sine is the height, the y-coordinate, is asking you what's the y-coordinate right here. And the y-coordinate right here is just 1. What is the tangent of pi over 3? Well, that one's a little bit tricky. Pi over 3, turns out that's this guy up here. How I know that is this is pi. So if you kind of divide things into thirds, here's the first third, here's the second third, there's the third third. Here's pi over 3 up here. And it's probably going to be beneficial to fill in, well, whatever. The coordinates here, if you have your unit circle all memorized, this x-coordinate is 1/2. And the y-coordinate is the square root of 3 over 2. Whereas this x-coordinate is 0 and the y-coordinate was 1. That's why the sine of pi over 2 was 1. Here I'm asking for the tangent, and the tangent is equal to, let's see, the sine over the cosine, or maybe at this point just y over x. So since this is my y-coordinate and this is my x-coordinate, I would say that's equal to the square root of 3 over 2 divided by 1/2. Which is not simplified, but I can simplify that if I remember that dividing fractions is kind of like multiplying fractions, but you multiply by the reciprocal. So this is root 3 over 2 times 2 over 1. And this 2 and the 2 and 2 over 1 would cancel, and you'd be left with just root 3. Secant of 4 pi over 3. Well, 4 pi over 3 is 1 1/3 pi. So here's 1, and you need another third. That's going to get you down here somewhere. In fact, the coordinates here are going to be very similar to the coordinates here, just negative. Right? Instead of the x-coordinate being 1/2, it's going to be negative 1/2. And instead of the y-coordinate being the square root of 3 over 2, it's going to be the negative of the square root of 3 over 2. So then when it asks me for secant, I have to remember that secant is 1 over cosine, or at this point in the class, maybe it's just 1 over x. Let's see, my x-coordinate is negative 1/2, so it would be 1 divided by negative 1/2. if you think about this as 1 over 1 divided by negative 1/2, and you can change it from a division problem into a multiplication problem and get negative 2 as your answer. Cosine of 11 pi over 6. A couple ways you can think about this. I think the easiest way is to realize this is damn near 2 pi. If it were 12 pi over 6, it would be 2 pi. But it's not. It's 1/6 short. Since pi over 6 is right here, 1/6 short of all the way around would be something like this. This is 11 pi over 6. And to figure out the x and y coordinates, I guess this again comes from your unit circle. Your x coordinate is going to be the square root of 3 over 2, and your y coordinate is going to be negative 1/2. And so if they ask you something like, what's the cosine of 11 pi over 6, you stare at this thing and you say, well, the cosine is the x coordinate, so it is the square root of 3 divided by 2. One more, the cotangent of 5 pi over 6. Do I have that one on here yet? Doesn't look like I do. Okay, 5 pi over 6 is damn near pi. If it were 6 pi over 6, it would be pi. It'd be right here. But it's not quite there. It's 1/6 short. I'm talking about this point right here. This is 5 pi over 6. And the coordinates here are much like the coordinates here, which are much like the coordinates here. I just have to be careful of the sign. My x coordinate is negative. It's negative square root of 3 over 2. And my y coordinate is positive, positive 1/2. So if you ask me for the cotangent, I have to know that the cotangent is cosine over sine, or at this point in the class, it's x over y. And so the x is the negative of the square root of 3 over 2. Maybe I'll write that a little differently. And divided by the y, which is 1/2. And if you change this from a division problem to a multiplication problem by multiplying by the reciprocal, you get negative square root of 3. And one thing I don't like about this, I'm going to change this problem. I already did tangent up there, damn. I am going to make this problem, instead of, I want you to rationalize, basically, is what I'm getting at here. So to rationalize, I would need the x coordinate to be on the bottom, so I would want 1 over cosine. So I would want to ask you, what is the secant of 5 pi over 6? So instead of this question, I'm going to ask you this question. And to answer this question, you have to know that the secant is 1 over cosine for this point. Cosine is the x coordinate, so it's 1 divided by the negative of the square root of 3 divided by 2. And if you multiply by the reciprocal, this is 1 over 1, what you'll end up with is maybe negative 2 divided by the square root of 3. But this won't work as your answer because you have to rationalize the denominator. You multiply the top and the bottom by the square root of 3, and you get negative 2 root 3 divided by 3. This right here will work as your answer, and that will end this quiz.